Hey guys, and welcome to this next video in our Properties of Geometric Figures series. This one is all about congruent triangles. Now, congruent triangles are triangles that are exactly the same. They are identical. Okay, and we're going to apply this idea of things being identical to each other to triangles. It's a really good starting point for congruency. Now, congruency in triangles, we've got some tests that we're going to look at. We're going to look at what it means, how to write the statement, what the tests are, and how to write a proof. So what does congruent mean? Well, we've already sort of mentioned that. Congruent means identical. All right, or shapes that are exactly the same. That is congruency. Now, what is a congruency statement? Well, a congruency statement is essentially what we write to say that things are congruent. So it's the answer of are these two shapes congruent? Well, what we would do is we would write the congruency statement. Now, for triangles, say we had a triangle that was ABC. Let's whip up some triangles here. Let's go ABC, ABC, and let's draw another one. Poorly drawn triangles there. And let's call this one D. Let's call this one D. DF. Put the F there and we'll put the E here. So it's DEF. And I wanted to say that these two triangles were congruent. And let's do a little bit that will prove that. What we will do is we would say triangle ABC. Alright, so if these are congruent, so if these two triangles are congruent. Okay, this is what we're going to be saying. We're going to say triangle. Alright, and we just use a little triangle symbol just like that one. Looks like the delta letter from Greek alphabet that you'll see another time, but for the moment we're using that as the triangle. We're going to say that triangle ABC is congruent, and we're going to use these three horizontal lines, and we want the letters to match up. So A matches up with E, so we want the E there. B matches up with F, and C matches up with D. So triangle ABC is congruent, and that's that little symbol, to triangle EFD. So let's make a quick note of that this is the symbol for congruency. Okay, just three horizontal lines, the symbol for congruency. Let's jump into the test now. So here's our statement. The tests we're going to look at will lead you to be able to making those statements. Let's have a look at the first one. There's 4 to be done. Let's look at the first one. The first one is called SSS. Triple S. And it's triple S because there are 3 pairs of matching sides, of matching or equal sides. So that's congruent. So all 3 sides of the triangle must have a matching side that is equal to it in the other triangle. So let's change my highlighter color. This side is the same as this side. Matching pair. This side is the same as this side. Matching pair. And we're the same here, so another matching pair. So that is 3 pairs of matching or equal sides. Our next test is called SAS. SAS. Now, we're not talking about the Special Air Service or the TV show or whatever. SAS is for side, angle, side. So what we want here are 2 corresponding, which is just a fancy way of saying matching, sides, and the included, write that a little bit better for you all, included angle. So included angle is the angle they actually make. And you can see in that diagram that the angle they actually make is here. And then we have our matching sides here and here. So you can actually see the angle is made by those 2 different lines or those 2 different sides. So that's SSS and SAS. Next ones. Our third one there is AAS. AAS. And this one are 2 corresponding angles. So we have 2 corresponding angles being equal. And then we just have one of the other sides. Okay, so we want 2 of the angles, 2 pairs of matching angles to be in there for this one. What that means is that the third angle has to be the same. So we don't need to worry about using an angle proof. 2 angles is enough there, and then we just want to make sure that one of the matching pairs of sides is also equal, simply because that will mean that we are congruent, not just similar. If we only use the 3 angles, we're going to be looking at similarity, which is something we're going to look at in a future video. Looking now at our last test. Our last test is RHS. Now the reason it's RHS is because we're looking for a right angle, which will be a matching or corresponding angle, because all right angles are equal or are 90 degrees. Alright, we want the hypotenuse and one other pair of matching sides. All to be equal. Okay, I might need to pop this up here as well. Let's get rid of that. There, oops. Alright, so everything has to be equal. So they're the 4 tests. Apply them as needed. If you see the right angle, use the right angle test. If you've only got the 3 sides, use the 3-side test. If you've got an angle and 2 sides, but it's not the included angle, maybe try to find another method. Okay. How do we write proofs when we're talking about congruency? Well, here's an example. We have 2 triangles here, ABC and EFD, and we want to be able to write that as a proof. So, what we do is we will write down all the things that we know. So in triangle ABC and triangle EFD, we know a bunch of stuff. So we know that the side of AB is equal to the side of EF. And that is actually given to us in the diagram. Right? Given in the diagram. Similarly, the side BC is equal to the side FD. Again, that's given to us in the diagram. AC is equal to ED. Once again, given in the diagram. Therefore, don't have to do anything else now because we've just applied the side to side to side or the triple S test to say that angle ABC is congruent, and we have the 3 horizontal lines, to triangle EFD based on the triple S test. And that is literally all you have to do for a proof. All your answers will be in the diagram, or you can use the things in the diagram to find your answer. Quick look at some examples. We are going to prove that these triangles are congruent. Okay, let's look at the first one. So we have 3 sides given. Let's look at our corresponding sides. Here's a corresponding set of sides. Here's a corresponding set of sides. Corresponding set of sides. So in these 2 triangles, so in triangle ABC and triangle DEF, we know some stuff. So we know that AB equals DE, and that's given. We know that BC or CB is equal to EF, also given. We also know that AC and DE, or DF rather, DF are the same, given in our diagrams. And that's all you have to do as a reason. The reason they're called proofs is you are given reasons for your responses. Therefore, triangle ABC is congruent with triangle DEF. Let's do one more to show what we are up to. Here we have 2 more triangles. And let's go. In triangle ABC and triangle, what do we got here? We've got DEF. Alright, we know a bunch of stuff. So we know that AB is equal to DE, given in our diagram. Boom, boom. They're equal. We also know that angle BAC is equal to angle EDF. Again, given. Now remembering that the middle letter should be the vertex when you're writing angles. And then we want AC to be equal to DF. Again, given in the diagram. Therefore, triangle ABC is congruent to triangle DEF. Literally all it takes. All the answers will be in your diagrams or easy to extrapolate from your diagrams. We're going to finish up there. Hopefully this has been informative and helpful. Good luck with your questions, and I'll see you in the next video.